Um, first thing, just to remind you these, right? When I say a log function, it means something like that, right? Where you got log base A with an x there equals y. Well, you'll actually have numbers in there. Sometimes you might have like a variable to solve for. The biggest things to point out, just to remind you, right? Because logs are essentially just another way to write an exponent. Right? So, and that's the whole point of these is so that when you get to the stuff next class on Wednesday, you use the logs to solve exponential functions, right? It's a way to take a variable that's on in the exponent and drop it down to the regular level like a linear equation so you can actually solve it like a normal one you would have done as a 1, as opposed to looking at it as an exponent and trying to graph things out and relying on calculator y. Okay, so the biggest thing to remember is the base, right? Remember the base in an exponent is whatever you consider your regular number out in front. The thing on the right-hand side with this log is always whatever the exponent is. As long as you can keep those two in order, it's really hard to screw these up.
Might be the pink panther.
All right, so look, your most basic ones would be ones like this where they have, log base 2 base, and they'll say like evaluate. And it's just you got to remember that you're trying to figure out what power you would raise 2 to get 8. Okay, or they might say like evaluate this, and you would put 4 because 3 to the 4th power gives you 81. Right? That's the big thing to remember as soon as there's a report.
Isn't 3 to the second 9?
It's not 3 to the second. The base is 2.
Or 2 to the third?
2 times 2 is 4 times 2.
Wait, is it 3 to the second or 2 to the third?
Base, so that's the base, that's the power. Okay?
That wasn't it.
Don't touch calculator. You don't need it. All right, now, the properties, there's 4 of these. The same ones are going to come up with the natural logs, but when we do the natural log stuff, I'm going to have it rewritten in the form dealing with bases of E. All right, so there's 4 main properties. This isn't dealing with like the expanding ones or bringing them back together. This is just simply basic properties. All right, so first thing would be log of any base that has a 1 but with 0. This would technically be a to the 0 power. And remember, anything to the 0 power is always 1. Doesn't matter what the base is. If you've got a 1 right there, your answer is always 0. All right, next thing would be that if the base and the number you have right here are exactly the same, this always evaluates to 1. Okay, but this would be like, right, if I wrote this as exponents, this would be a to the 1st power. Which anything raised to the 1st power is exactly the same as whatever it is. All right, next one, just remember that. Okay, this is just saying this base raised to this power. If you have the exact same thing here, it just drops that x down to the front. So this would say, if I wrote this as an exponent, this would be a to the x power equals a to the x, which makes sense. Okay. Ones like this you'll come up with. Well, I have one. This is the other one. This is all raised to the power. It's just the best I can do with the whole typing thing there. This is like a all raised to the log base a of x.
You can do that?
Okay. Do whatever you want with it.
All my numbers are
Raise it to another power. Yeah, it's just the best I can do.
No, I'm going to 1 for it.
I expect it to be a bit slow. All right, now guys, with these right here, the types of problems that you do is like basic ones, do ones like that. We'll say like evaluate the log, like that equals 4. I was doing that. All right, like you would have that right there, and it would be like, okay, I got to evaluate that Remember, you can't technically do it in the calculator just typing in log 5 to the 4th power. Because the log in the calculator is a different base. But this would just be you going, oh, this property and that would match up. So this base and that number are the same, so that means my answer is whatever the power is. So I got the 4. Okay? And then the same thing as if I had like if I did the same thing, guys, and I said, what's log base minus 9? That's what? 1. Okay, so it all builds on this, right?
Wait.
Start, these are your basic properties. Oh, yeah.
Can you do a number 4 one? I don't understand what that is.
Just give me a number.
Like a 4
2?
Yeah.
2 log base 2 to the 10 equals. That's what it would look like. This number and that one are the same. This is the answer.
So it's kind of
They
like,
have to match up. It's a matter of, like, these properties are just a matter of you trying to see if you've got repeated numbers in specific.
so that one is just like the 3.
It's like 3, it's just written a little bit more. 3 and 4 are pretty much the same kind of idea. Yeah. Okay? All right, now, next thing. Can I go past this, guys? Not.
We should go here. Did you say like,
Well, I'm gonna go anyway, you're right. Okay, now, the next thing, okay? Wait, yeah.
okay, so logs are just another way to write exponents?
Yes, that's all it is. Like I said, it's used mostly for solving exponential equations. Okay, the next two things, guys, just so you know the basics, just to remind you of this especially, right? The common logarithm, that's your base 10. Remember, guys, the common logarithm, the base 10 one, that's the one that's in the calculator, right? Just in case you forgot, like the log button on calculator is base 10. So in your calculator, if you did like, let's say log of, I don't know, 100 or something like that. That should give you an answer, right? If you do log of 100 in the calculator, that does give you a numerical answer, correct? And it should be 2. Okay? Same thing as this. Log of 10 should be 1. Because again, base 10, and this is, guys, just I'm doing all this so you remember, log base 10 and that in the calculator are the same. So pretty much anywhere, if you see log just by itself, it's always referencing base 10.
All right.
Okay? Then natural logs, remember that's base E. But instead of writing base E, of course we use ln. Right? Log base E is essentially ln. So the ln button right on the calculator is the natural log, which is just simply your log with the base B. Okay? And if you remember, guys, just so you can further get it, right? If I did like ln of 5, okay, that should give you a number in the calculator, right? So ln of 5 is what? What's ln of 5?
1.6.
1.6. So if I said something like ln of 5, and I went to the calculator and said evaluate, you got 1.6. Just remember, what this is actually saying, this is the same thing as, right, e to the 1.6. So e to the 1.6 should give you 5, or close to it, because, you know, you rounded to 1.6. All right, so it should be fairly close, unless you're rounding way off. Okay?
Ellen is right under log. Oh, well. Where's log? Ellen.
Oh, good.
Yeah. Okay, so
I am. What you gonna do about it? Wait, is this in 5? What?
Ellen, you're not doing anything.
All right, next thing, guys. Like I said, I'm gonna have these properties that were just up there, rewritten in the form for natural logs. Okay. All right, hold on. So the properties are exactly the same, but since natural log, right, the base has changed. That means some of the stuff you'll see here is written a little differently, like where I just have it written with different bases. Okay, so the first property is the same. The second property is the same, but just since natural log is base E, the E has to be there when using ln for an equal 1. Okay? So again, it's the same as the second property I had up there, which had the log base A. In this case, natural log is always base E, so this is always a consistent thing. Alright, next one would be like that. Alright, and the last one would be like that. So all those are exactly the same. It's just a matter of seeing it a little different, just in terms of bases. And these can be rewritten because, right, natural log is always base E. So you can always rewrite it in that fashion. You don't have to change it like A's and X's and whatever we had up there.
Is that the last one? Is it E to the ln times X?
Power. That's all one power. E to the ln X.
So is it like ln times X?
So if I did like E to ln of 5, then that's just 5.
Oh, okay.
Right? Because ln of 5 is a number, but E to that number. It's almost like we just said, right? Like if I did that, that's just 7. All right. Next thing, okay? In case you forgot this, right? Change the base formula. This is what's used if you want to evaluate different logs of bases other than 10 in the calculator. Well, other than 10 in, of course, E. You remember change of base, guys, the way it works is if I say take the log of base B of like 10, or like if I did like log base 3 of like 80. If I said tell me what that is, the way you do this is you do log of whatever number's right here, wherever that X is. Remember, you're plugging in numbers divided by log of whatever the base is. And when I put log, remember I'm talking about base 10, so this is something you can actually do in the calculator. So I said log base 3 of 80, and I wanted that evaluated as a decimal. The way I would evaluate it is I would go log 80 divided by log 3. Okay, like that's how I would get it in the calculator. Because your calculator can calculate logs of base 10. It's just you have to switch it because the calculator doesn't do log of base 3. So if I did this, what's log 80 divided by log 3? 3 point what? 3.9. So 4. It's hey, and this one, guys, I put 0.0, right? Because if it was exactly 4, that would be 81, not 80. So it is rounded up to 4. Okay? All right. Next thing.
For the change base, can you just put that into your calculator as log 80 over log of 3, or you have to do log 80 first and then sign into that?
You can put it in.
You can put it on once. Because it should group it.
Wait,
if
so
you're not sure, just put parentheses.
okay, so that like I don't understand, what is the change of base thing? Like, wouldn't that just be?
Because if I gave you one, like if I said I want you to evaluate log base 4 of like 1, right? I said I want a numerical answer. Your calculator doesn't do log base 4. So the change of base just allows you to change this so that you can actually put it in the calculator. Because your calculator can calculate log base 10 of 20 and log base. All right,
So
it's just a matter of
you
you getting. It's a matter of you being able to evaluate. Okay. That's the whole point of having to change the base, at least for right now. All right?
Oh, wait. Okay, so the answer to that is 4, but,
No, the answer to that is this. Do it.
But then when you-
2 log 20 divided by log 4. It should be like 2.3 or 4.
2.16.
2.16, 1.2. So anyway, do that. Because I know, because look, what this is technically saying, like if I say, what is
It's
that?
like 4
Or if I put an X there, it's asking me what power would I raise 4 to get 20. So the change of base allows you basically to solve that. All right, guys, the next thing. This deals with doing like expanding or even simplifying things with logs. So the 2 first properties are probably the ones that are going to come up the most in terms of if I take 2 numbers and multiply them together, which for what we're going to use this for, it's not necessarily going to be 2 numbers. It's going to be things like x's and y's and so on. So if you take the log of 2 things multiplied together, you can always split them apart and do the log of each part. Okay, the a and b just added together. You remember, if you divide them, you can split it apart into the 2 logs subtracted. Right? And then the only other one to deal with is that one, where if you take something, raise it to a power, take the log of it, that power can just drop to the front of the log. Okay? Alright, and what's going to happen is, like, the way these laws are going to be applied right now, you're going to have problems where you're going to evaluate, and you're going to have problems where you're going to be doing, like, expanding them also. Okay, so, just to show you examples, this would be like one thing you might do. All right, where it's got 2 logs. And here's the thing, you know, with this one here, I want you, if I asked you to do this, guys, I would want you to get to an exact answer or something where you can, you know, quickly evaluate it. Now, I understand both of these I have just written as log, right? So I could technically go in the calculator and do log 4 plus log 25. Okay? And it should get you the correct answer. But the thing is, if I change the base on this, you wouldn't necessarily be able to do that right away. Okay? And the whole point of having a problem like this is so you realize that both these logs are the same base. I'm saying add it up. So if I add this, I can simplify this to log of 4 times 25. Right? And 4 times 25 is 100. So log base 10 of 100 should give you 2. Like, without touching the calculator, you should be able to do that. Okay? Because 10 squared gives you 100. All right? So that's how, like, that's one way this is going to be used, is doing evaluations like that. All right? If I made it a little longer, obviously I couldn't go into the calculator and like just do this all in one swoop unless you did a whole bunch of change of base for me. Okay? But even with this, you might take you way too long. So if I was doing this one, first thing I would notice is all the bases are the same. Right? So since all the bases are the same, I can combine these into one log. Here I got subtraction, right? If I take these 2 that are subtracted, that's the same as me dividing those numbers right there, the 6 and 15. And then if I take those and add something else to it, you've got to kind of think, base is the same. I see a plus that's the equivalent of multiplying. So I can put all those together as 6 divided by 15 times 21. All right? And if I do that, right?
I don't understand how you just got all that 6 over 15. You can just,
That means divide.
Because I'm doing these laws, but I'm doing backwards. If I got a subtraction, I can divide them, as long as the bases are the same. And every base here is base 2. So all I did is I said, I can divide these two numbers. Okay? And then right here, since that's a plus, plus is essentially the same as multiply. So what you need to think of is with logs, when they're separated, subtraction equals dividing the numbers, adding equals multiply. Anywhere you see a subtracting divide, you'll see a plus. So I know I'm actually, if I just put this in times 1, and we multiply that. All right, so here's the thing. What is 6 divided by 15 times 20?
I don't know.
8.
24 over 3 is 8.
No, 8.
And log base 2 of 8 is what?
Oh, you could use the cheese sauce.
3. Why? It's just 3. Right? Because it's 2 cubed is 8. The other thing you're going to do with the laws of log stuff is going to be taking a log and expanding it. I've got, you're going to have variables in these, which means you can't technically evaluate them unless you knew what the value of x is you're plugging in, which you don't here. So all it's asking you to do is take the log and expand it as much as you can. Okay, so it's into one single line of either adding, subtracting, multiplying. Okay, so with this one here, right, the first one I would go, look, I know this is x divided by 2. So the way you need to think about it is if I've got division with the log, that's the same thing as subtracting. Yeah. Okay? And that'd be it. That's all it's asking you to do. This would be a pretty basic one. That's like a one-step one. Not a big deal.
Yeah.
Just saying, take it, expand it as far as you can. That's as far as I can go with it. You don't need to like get the actual value of log base 5 and 2. Okay? That just stays what it is. Right? It's just matter. It's doing the same kind of thing I had with the evaluating. It's just in the reverse order. All right? This one's a little bit bigger. Okay? Actually, let me do a different one first. Actually, let me save this one. This will be the last one I do. Before this, let me do log base 3 of squared to the 5th.
Oh, okay.
Okay? So this would be, if I look in the parentheses, right? In the parentheses I've got two things multiplied. I got 2 and x squared multiplied together. So that means somewhere I'm going to have logs added together. I also have a whole term right here raised to a power. First thing I would do is drop the power to the front. Okay, power always needs to get dropped to the front. So that 5 move to the front of it. And I've got 2x squared there. Okay, one thing to remember as I go through this, guys, this is all grouped. This whole thing is multiplied by 5. Okay, now, next thing I would do is I've got 2 times x squared. So again, if I've got the log of 2 things multiplied together, I would expand that to those 2 added. All right, and I'm going kind of step by step on this one. You could probably skip some of these steps as you're going through. All right. Now the next thing I would see is like the first one, the first log is fine. It's a number. I don't need the number, but it's fine. I can't do anything else to it. Over here, I still have a number there raised to a power. So I still need to do one more step, and that's to break that up. Okay. Wow. Like that. And then the last thing would be I can distribute the 5 to both of them. So this will become 5 log base 3 of 2 plus 10 log base. Why did I drop it? 3 log base 3 of x. So that would be the final answer for expanding that one. Okay? So powers drop to the front, multiplication ones go together. Okay? The reason I wanted to do this first is to do an easier one with the power first before we do the square root one. The square root one usually screws people up. Can I go past this, guys?
No, wait, I'm not done.
Oh, come on, Mom.
Jeez.
Oh, okay, I get it.
All right, so this will be the last one, okay?
All right. Let's
First thing you got to remember, right? Square root. Square root is the same as something raised to the 1/2. Right? It's something you should like automatically remember and utilize here. And the reason for that is so that you realize, look, that's a log to something raised to a power. Power drops to the front. And then the only other thing really you have to do here is realize those two are divided, correct? With logs, we got two things divided, just like up here, I'm going to subtract them. But remember, the 1/2 is multiplying by everything. Okay? So I'm not going to write the parentheses here, I was going to write that just to remind you that. So it's going to be 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1.
And you don't have to do anything else with the x minus 1, x plus 1.
That's it. Okay?